Hey everyone, so today we're going to be doing translations, which is the first basic rigid motion. So the title of today's notes is Translations. Please don't forget to put the date. Our learning target is I will be able to perform and identify translations on objects. So remember from yesterday's lesson, the three transformations that we learned were translation, reflections, and rotations. The way we think about a translation is a slide. Reflections are flips, and rotations are turns. And since these don't change the size or the shape of the figure, these are all basic rigid motions, or BRMs for short. So another definition we're adding today is a translation is sliding a figure from one position to another without turning it along a vector. So if we don't know what vector is, that's okay. We'll define it later on this page. So since a translation doesn't change the size or shape, it is a basic rigid motion, which means the pre-image, or the original figure, is this symbol to image. And this symbol means congruent and we can define congruent real quick. And congruent just means size and shape are equal. Please make sure to put all definitions with their page number, or certainly all the vocab words with their page number in your glossary. So again, translation, we slide a figure from one point to another. So we start with a pre-image, we translate it or slide it to an image, and then we along a vector, and we know that the pre-image is the exact same size and shape as the image, which means the pre-image is congruent to the image. So let's take a look at example 1 here. Example 1, we have JKL, which means it's a triangle with the points J is negative 3, 4, K is 1, 3, and L is negative 4, 1. So please take time, pause the video, and please graph triangle JKL. Now let's graph the other triangle, J apostrophe, K apostrophe, L apostrophe, with the points negative 1, 1, or negative 1, negative 1, 3, negative 2, and negative 4, negative 2. So please pause the video again and graph that triangle. So if you have graphed your two triangles, should have something that looks like this, where my JKL are in blue, and my J apostrophe, K apostrophe, L apostrophe are in red. So you might think, okay, it's not really an apostrophe in math. This is called a prime. So if we have J apostrophe, we say this as J prime. So all this means is that if we're looking at a prime, we know we're looking at the image. So primes are attached to images. If we have no primes on our figure, then we know we're looking at the original figure, which is the image. Or this, excuse me, if we're looking at the original figure, it has no primes, it is the free image. So you might ask yourself, okay, so I kind of went ahead here. You might ask yourself, okay, what does J apostrophe mean? J apostrophe, we say in math, it's called J prime. So primes are connected to the images. So if it has no primes on them, we know we're looking at the original copy, which is the free image. So if we had J prime prime, this is called J double prime, which means that the original figure, the pre-image, was transformed twice. So if you can see here, all we have to do is go right 2, down 5 to go from J to J prime. So right 2, 1, 2, 1, 2, then down 5 maps the pre-image J to the image J prime, and that should work for all the other points as well. It works for K to K prime, and it works for L to L prime. So right 2, down 5 is our translation or our description. Right 2, down 5. So what we know, so this is now a specific length. Okay? So I already drew an arrow. No matter where this arrow is on this paper, it's always right 2, down 5. So I can drag this arrow, K to K prime, J to J prime, L to L prime. This arrow is called a vector. So a vector is an arrow with a specific length and direction. So we can look at the example here with these two vectors. So let's say this is A, and B. Is this true? And we'll go over this together as a class. Is the vector AB, and we use a symbol of a half arrow, equal to vector BA? And again, we'll go over this as a class. So we can also write our description of our vector. So right 2, down 5, we can put this in vector form. Vector form, so since we're working with translations, it's a capital T. And again, the symbol for vector is a half arrow on top. And I'd say since it's right 2, right, it's in the positive direction, so this is just simply 2. Down 5, down is in the negative direction, so this would be 2, comma, negative 5. So we always write our vector as T with a half arrow. We put the left and right first, and we put the up and down second. Just like how we'd write a point, where if we had, X, comma, Y, same idea. We could also say the rule is, so our rule is written with X and Y, so our rule would be, since X comes first, right, it's positive, so it'd be x plus 2, comma, then y, it's the second letter, minus 5. So we have the rule, the vector, the rule in blue, the vector in black, and the description, which is in words, is in green. So let's try one example together before you guys move on to your independent practice. So we have triangle ABC. This symbol means triangle. ABC, so let's graph that. A is 4, -3. Okay. B is 0, 2, 0, 2. And C is 5, 1. Please draw this triangle. I know mine's not very good. Please try to draw a better triangle on your own notes. Okay, so it says, please translate. Translate means slide. 2 units to the left and 3 units up. So this is our description, which is in words. So our rule, we use x and y. X, y. 2 units to the left. 2. The left is negative, so it's x minus 2. 3 units up. 3 units up. Up is positive, so it's y plus 3. So this is our rule and our description. Okay, so please try to do this on your own. Once we are done, please have me come check it, and I'll give you your independent practice.